Hello students, welcome to the fourth session of today's topic number system. In the previous topics, we have discussed about the decimal presentation of rational numbers, irrational numbers, the classifications of the decimal numbers into a real number system, inserting any real number between any two given real numbers, how to present the rational numbers and irrational numbers on the number line. All these things we have discussed. Now today we'll learn about how to operate the real numbers. In operation of real numbers, as we already know, the real numbers we categorized into two basic things. One is rational number, other is irrational number. So how to present them, how to operate them, let us learn today. We have already learned the operation of rational numbers, but just have a look on that. When we operate rational numbers, how we operate? So operations on rational numbers. Operations on rational numbers. Now when two rational numbers I operate, two rational numbers, suppose I will operate one rational number is x1 with another rational number is x2. You will find always the answer is belong to a rational number. That means we can say the addition of this rational numbers is closed. That means here I can find this x1, x2 and x3 all belong to the rational number. All are rational numbers. Similarly, if you subtract a rational number from another rational number, suppose this is x4, I am subtracting x5 from it, I will find it is x6. So here also you will find this x4, x5 and x6 all are rational numbers. When you multiply two rational numbers, we always find a rational number. Similarly, it is suppose x7, I am multiplying with x8. This x7, x8 I am taking a rational numbers. So the product if I will get it is x9, then I will find all these numbers x7, x8 and x9 all are also rational numbers. When we divide a rational number, suppose x10, I am dividing with another number x11, I will find another rational number x12. Condition is that this x10, x11 and x12 all are rational numbers except this x11th should not be equal to 0. This should not be equal to 0. We should not divide this rational number, the divisor should not be 0. Except 0, if we divide any rational number with any other rational number, we will find the quotient is definitely a rational number. So here we get an idea that when we operate two rational numbers, we always find a rational number. Except the division case, that is a 0 should not be divided. But the same thing, does it happens to the irrational numbers? So what happens in such case when you operate a rational number with an irrational numbers? Let us see. When we operate a rational number with an irrational number, we find this result is always an irrational number. For example, I will take a rational number, suppose 2. I will add with a irrational number, let us take it as 5 root 5. So the sum will always be a irrational number. So this will belong to q dash, as we have taken the irrational number set is q dash. So 2 plus root 5, this becomes an irrational number. So I operated a rational number with an irrational number, I find the result is an irrational number. Similarly, if I will take 3 as a rational number, I will subtract suppose root 2 from it, I will find 3 minus root 2 also an irrational number. So difference of two real numbers, that means one is rational, other is irrational. Even if I will change this order, I will find the same number, the result will always come to an irrational number. Then next, if I divide one number, suppose I have a 4 root 5. 4 root 5. I divide with 2. This 4 root 5 is an irrational number. I am dividing this 2 as a rational number. So I will find the result is this 4 will be cancelled by 2 and finally I will get it is 2 root 5. This 2 root 5 belong to also irrational number. If I would have done 2 by 4 root 5, even if I would got a rational number again. Look at here now, this 2 can be cancelled with the 4. I will find it is 1 by 2 root 5 even if this is a irrational number. So this gives us idea that whenever we operate a rational number, we divide a rational number with an irrational number, the result always gives an irrational number. Now let us go to multiplication. When you multiply, suppose I will go to find a multiplication, I will multiply 4 with 3 root 5 suppose. When I multiply 4 with 3 root 5, I will find it is 12 root 5. 4 with 2 root 5, 3 root 5, it becomes 12 root 5. Here 4 is a rational number, 3 root 5 is irrational number and the product is also irrational number. So in all these cases we know that operation of a rational number with an irrational number always gives the result is irrational. We have observed that 2 plus root 5 is irrational number, 3 minus root 2 is irrational number, 4 root 5 divided by 2 becomes 2 root 5 which is an irrational number, 2 by 4 root 5 which is equal to 1 by 2 root 5 which also is an irrational number. When I multiplied 4 into 3 root 5, 4 is a rational number, 3 root 5 is an irrational number, the product becomes again irrational number. So in all these cases I find that we operate two numbers, one is rational, other is irrational, the product or the result is always coming as irrational. Okay, but does it happens in case of when we operate two irrational numbers together? Will it give always irrational number? Like rational numbers, when we operated two rational numbers, we always get a rational number. Similarly, when we operate two irrational numbers, will we get the result is always irrational? Let us observe. Now, when we operate two irrational numbers, that means we can operate by addition, we can operate by difference, subtraction, we can operate by multiplication and division. In all these cases, we'll find what is coming actually there. So, operations of two irrational numbers. Let me operate operation of two irrational numbers. I have taken two irrational number. Operations of two irrational numbers. Now when I operate two irrational numbers, let me take a irrational number. I will think it is 2 root 3. 2 root 3 is an irrational number. I have already found that 2 is a rational, root 3 is a irrational, the product is irrational. So 2 root 3 is a irrational number I have chosen. Now let me choose one more irrational number. With it is root 3. So now 2 root 3 I have added with root 3. This becomes now 3 root 3. Now 2 root 3 plus root 3 is become 3 root 3. Here it is irrational, here it is irrational. Now I also got the result is irrational. But does it happen to every case? Let me find one more. Let me take another example, 2 minus root 3. Now 2 minus root 3 is a single number I operate. 2 is a rational, root 3 is a irrational, 2 minus root 3 together is a irrational number. Now this is my irrational number. I have to add this number with another irrational number. Let me root 3. Let I take root 3. So 2 minus root 3 plus root 3. This becomes now, when I open the bracket, I find it is minus root 3 plus root 3. They became cancelled and answer became 2. So this gives us sum of two irrational numbers. Here I got it is irrational number. And sum of two irrational numbers, here I got it is rational number. That we cannot say when we add two irrational numbers whether it will be a rational number or irrational number. It may be a rational number, may be an irrational number also. Okay, it depends upon the number what we are adding. Let us see in difference case what happens. Let me rub this. When we subtract, suppose I will have 2 root 3 minus root 3. Look at it, 2 root 3 is an irrational number I have taken. Root 3 is another irrational number I have taken. So 2 root 3 minus root 3 is again become it is root 3. So how it became root 3? I have taken root 3 common, then remaining is 2 minus 1, 2 minus 1 is 1. So 1 into root 3 becomes root 3. So 2 root 3 minus root 3 equal to root 3. Now this is irrational, and the result is also irrational. Now let us find in addition case, difference case. Another case, 2 plus root 3 minus root 3. Now 2 plus root 3 I have taken as a single number because 2 is a rational number, root 3 is an irrational number. The sum of a rational plus irrational we have already find it is irrational. So 2 plus root 3 is an irrational number. Now 2 plus root 3 I have subtracted from with root 3. So what will get at here now? After opening the bracket, I will find this root 3 and root 3 will be cancelled. Plus root 3 minus root 3 will cancel. Answer will be 2. Okay. In this case, I find the difference of two irrational numbers is an irrational number. And in this case, I find the difference of two irrational numbers becomes a rational number. So here also we cannot say the difference of two irrational numbers will always be a irrational number or rational number. It depends upon the numbers what we are operating. Okay, this gives us idea that difference of two irrational numbers may be rational, may be irrational too. Okay, let us go to for multiplication. When you multiply two numbers, two irrational numbers, you multiply. Suppose let me take it is root 3. I am multiplying with another rational number. Let us take again root 3. So root 3 into root 3, I got it is 3. 3 is a rational number. Got or not? So when I multiply root 3 into root 3, I got 3. 3 is a rational number. That means product of two irrational numbers, I got it is rational. Now let me take again it is root 2. I multiplied with root 3. I got it is root 6. Now root 2 is irrational, root 3 is irrational, and the product is also irrational. So this becomes now irrational. Again we conclude that product of two irrationals also cannot be said as rational or irrational. It depends upon the number what we operate. So product of two irrationals can be irrational, can be rational also. Okay, let us go for division. In case of division, let me take 6 root 5. This is an irrational number, definitely. I will divide with another irrational number. Let us take 3 root 5. 3 root 5 is also an irrational number. So when 6 root 5 is divided by 3 root 5, I find the answer root 5 is getting cancelled. 6 is getting cancelled by 3 and finally answer is 2. This 2 belong to Q or rational number. That means I operated two irrational numbers on division and I find the result is an rational number. Now let me find another number. Suppose I will take 8 root 15. 8 root 15 is divided by now 2 root 5. I will take 2 root 5. So 8 root 15 when divided by 2 root 5, what will happen at here? 8 will be cancelled by 2. It will give 4. And root 15 is the product of, I can write it like this. I can write it is 4 into 2 into root 5 into root 3 divided by 2 into root 5. Now what are the common factors in both the numerator and denominator we can find? 2 is there, a factor in both the numerator and denominator I can cancel. So root 5 is there, I can cancel. So what is left? The leftover part is now 4 into root 3 is 4 root 3. Now this 4 root 3 is an irrational number. So I operated two irrational numbers with the division process and I find the result is also an irrational number. Now we also conclude the same, that when we operate two irrational numbers with a division process, we also get the result sometimes rational, sometimes irrational. It depends upon the number what we operate. Okay, so these are the operations, basic operations we learnt. The nature of operations when we operate two irrational numbers or two real numbers, what will be the result we learnt at here now. Okay, so let us go to the next. So let us find the more operations on this rational and irrational numbers. So we find whenever we write a number in rational form, generally we write in P by Q form. Suppose it is P and Q. It is called rational form. So in rational number case, we declare this P and Q are integers, and Q is not equal to 0. Q is not equal to 0. So in expressions, when we write sometimes like this, suppose I will write 1 by root 2, this is not at all a rational number, this is an irrational number. But this expression is called a rational expression. In such type of expressions, it is always we take this denominator should not be in the irrational form. So in order to keep this denominator not in irrational, so we have to multiply something to make it rational. So the process what we use for that is called rationalizing factor. So we find a rationalizing factor of this denominator to make this entire expression as rational. So what is that? So how we operate this? Let us learn now. Suppose 1 by root 2. I have 1 by root 2 with me. So in the denominator here, 1 by root 2, the denominator is root 2, which is irrational. So I want to make it rational. So what I will multiply? Very simply, I can find 1 by root 2 when I will multiply with root 2. 1 by root 2 when I multiply with root 2. Suppose this will be root 2 by root 2. So when the numerator will be multiplied, denominator will be multiplied root 2, in order to make it rationalize, I have to multiply root 2 to the numerator because I have to equivalent also. So I will find this answer is root 2 by 2. Now this is a standard expression where the denominator is rational. So anywhere I find the denominator is irrational, we have to make it rational. So in order to make it rational, we have to find some factor to be multiplied with that, which is called rationalizing factor. So let us see what are new rationalizing factors of different numbers we will find. Let us take one more example. I will find one more example. Suppose I will write it is 1 by 3 root 7. 1 by 3 root 7. So can you say what I will multiply with this 1 by 3 root 7 in order to make it rationalize? So 1 by 3 root 7, I can write it here 1 by 3 root 7. I need not to multiply 3 root 7 in the denominator and 3 root 7 in the numerator. But that I can multiply root 7 at here also and root 7 at here. So this will give us root 7 into 1 is root 7 in the numerator, and 3 root 7 into root 7 is root 7 into root 7 becomes 7, and 7 into 3 becomes 21. This root 7 by 21, this expression is now converted into root 7 by 21. Here the difference is that both of their values are equal, but here the denominator is irrational and the denominator is rational. This is the difference. Okay, we have to make this denominator rational. So in order to make this denominator rational, we find there are different types of rationalizing factors according to the denominators we have seen. Let us go to one more example. We will see. Okay, let me find one more number. It is, it is 2 plus root 3 by, suppose 2 plus root 3 by 7 minus 3 root 5 I will take. 7 minus 3 root 5. Look at here, numerator and denominator both are irrational. Numerator and denominator both are irrational. In such case, to make this denominator rationalize, so what I have to multiply? So I will keep 2 plus root 3 as the numerator and 7 minus 3 root 5 as denominator. So but I will think what I will multiply exactly at here. If I will multiply 7 minus 3 root 5 again, I have to multiply 7 minus 3 root 5 in the numerator also. But 7 minus 3 root 5 into 7 minus 3 root 5 cannot make it rationalize. So I will select if this term will be a square and this term will be a square. So something I will multiply so that each term, each individual term will be a square. So that is square root term will be eliminated. In order to think that, I have to multiply 7 plus 3 root 5 with the denominator. So if I am multiplying 7 plus 3 root 5 to the denominator, this is in a form of a minus b and it is in a form of a plus b. Here a is 7, b is 3 root 5. So it is 7 minus 3 root 5 is an a minus b, and here it is 7 plus 3 root 5 is an a plus b. When I multiply these two numbers, I will find it is a square minus b square, means 7 square minus 3 root 5 whole square. So 7 square becomes 49 and 3 root 5 square becomes 9 into 5 is 45. So in that case, you will find this denominator becomes completely rational. But in order to find make it rationalize equivalent, so I have to also multiply 7 plus 3 root 5 with the numerator. Now I multiply 7 plus 3 root 5 with the numerator, also 7 plus 3 root 5 with the denominator. So what I find out here now? So let me open this bracket and multiply each individual terms. So there are 2 terms which multiply with 2 terms. So I will find now 4 terms. So 2 with all these terms I can write 2 whole into 7 plus 3 root 5 plus root 3 into 7 plus 3 root 5 by distributive property of addition. And in the denominator, it is in the form of a minus b into a plus b. I can write it is 7 square minus 3 root 5 whole square. So I can find it here now. So it will be 2 whole into 7 plus 3 root 5. Again I will open 2 into 7, it is 14 plus 2 into 3 root 5 becomes 6 root 5 plus root 3 into 7 becomes 7 root 3 and root 3 into 3 root 5 is 3 root 15 whole divided by. Now what I have 7 square is 49 and 3 root 5 square, 3 square is 9, root 5 square is 5, so 9 into 5 is 45. So finally I can write the answer is, so here no terms are like terms to be added, so all the terms I will write individually. 14 plus 6 root 5 plus 7 root 3 plus 3 root 15 whole divided by 4. My purpose was to make this denominator rational, and I find in this expression, this answer, the numerator may be remain as irrational, but the denominator becomes rational. So actually I find the rationalizing the denominator. So in this expression, it should not be kept as the denominator irrational. So in order to make this denominator rational, I have to operate this process. This is called rationalizing the denominator. Okay, let us go to one more example. Okay, so where we find, so step of cases. We have observed when these terms are in the a minus b form, what we have to multiply. Let us find some more. Suppose I will write a new number. It is 1 by 2 plus root 2. 1 by 2 plus root 2. So 1 by 2 plus root 2, here the numerator is rational, denominator is irrational. And I want to make this denominator rationalize. So what I have to multiply with this term so that the denominator will be rationalized. So I can see from here the denominator is in a form of a plus b, where a is 2 and b is root 2. Now I will select immediately 1 by 2 plus root 2. I will take the rationalizing factor of the denominator as 2 minus root 2, because we have already seen when I find a plus b is multiplied with a minus b, the product gives a square minus b square. That means individual terms are getting squared, and so that the square root of this individual term will be eliminated. But simultaneously, in order to make it is equivalent, I have to also multiply 2 minus root 2 to the numerator. So now multiplying 2 minus root 2 both in numerator and denominator, we will get 2 minus root 2 divided by 2 square is 4 minus root 2 square is 2. Now 2 minus root 2 divided by 2. This is the final expression of this 1 by 2 plus root 2. So it was given 1 by 2 plus root 2, but we converted into 2 minus root 2 by 2. In this term, both the values are equal. Both these values are equal. But thing is that here the denominator is an irrational term and here the denominator is an rational term. Okay, so by this process we came in to know what is the rationalizing factor, how to detect the rationalizing factor of a denominator when it is given as irrational. Okay, we'll go to the next. Let us take some example. Okay, how this thing will be used in questions. Suppose I will select a point. Suppose let me take a question. If a equal to a, I have selected number a equal to 2 plus root 3. A is a number which I selected as 2 plus root 3. If a equal to 2 plus root 3, find the value of a minus 1 by a So this expression's value I have to find when a value is given 2 plus root 3. So value of a is given 2 plus root 3. I need to find the value of a minus 1 by a. Here we can see when I made 1 by a, that means 1 by 2 plus root 3, the denominator again becomes now irrational. So what I have to do for that, let us learn. So now what I will do now, a equal to 2 plus root 3, I will write a equal to 2 plus root 3. So next term I will find a 1 by a. So 1 by a I will find it is 1 by 2 plus root 3. Now as I cannot keep this denominator irrational, I have to make it rationalize. So in order to make it rationalize, I have to multiply something it. So what I will multiply it here? I will multiply 2 minus root 3 to the denominator, and in order to make this entire expression equivalent, I have to also multiply 2 minus root 3 in the numerator. So what answer I will get at here now? So numerator becomes 1 into 2 minus root 3. This becomes 2 minus root 3. And the denominator is in a form of a plus b into a minus b, where a is 2, b is root 3. So the answer will be a square minus b square. A is here 2, so 2 square minus root 3 square. So finally what I get? I got it in 2 minus root 3 divided by 2 square is 4 and root 3 square is 3. So 4 minus 3 is again 1. So 2 minus root 3 by 1. So 1 divided by something divided by 1 is the same number. So 2 minus root 3. Now I got 1 by a becomes 2 minus root 3. Now it was given a, but I could able to find this 1 by a equal to 2 minus root 3. Now I have to find a minus 1 by a. Now a value is already given to me. Let me take a is 2 plus root 3 minus, when it is 1 by a is given 2 minus root 3. So I will take it as 2 minus root 3 within bracket. Now I will open the bracket. 2 plus root 3 minus is multiplied with 2, it is minus 2. Minus is multiplied with minus root 3, it becomes now plus root 3. Now finally what I get? 2 minus 2 is getting cancelled. So root 3 plus root 3 becomes 2 root 3. So this is my answer. Okay. So 2 plus root 3 minus 2 minus root 3. Finally I got 2 root 3. So a minus 1 by a, I got it is 2 minus root 3. So if sometimes some number will be given like this, and how to operate to find that such expressions, we have to find like this. Okay, we'll go to the next example. Let me take how to find one more number. Let me go to question number 2. Suppose I will find if 7 plus root 5, suppose it is a given expression 7 plus root 5 by 7 minus root 5. 7 plus root 5 by 7 minus root 5 plus 7 minus root 5 by 7 plus root 5. And this is equal to a plus 7 by 11 root 5 into b. Look at it now. This is an expression. This is another expression. The sum of these two expressions is equalized with sum of another two expressions. So in such case, how to find the value of a and b? Find the value of a and b. So a and b, these two values I need to find. These two values I need to find, a and b. So how to find such value? Let us observe now. So go to the solution. So 7 plus root 5 by 7 minus root 5. It is 7 plus root 5 by 7 minus root 5 plus 7 minus root 5 by 7 plus root 5 and is equal to a plus 7 by 11 root 5 into b. Now I will give implies because I am solving it. Okay. So while solving, now by observing to the denominators, I find in both of these denominators, the denominators are already in the form of a plus b into a minus b. So I can go to rationalize individual denominators, or I can take the denominators as their LCM. So I will take the LCM is 7 minus root 5 into 7 plus root 5. So what happens in such case, I will take the LCM as 7 minus root 5 and 7 plus root 5. So both of them are multiplied and the denominator conversely become to rational. But when this LCM we divide with 7 minus root 5, I find it is 7 plus root 5, and it is multiplied with 7 plus root 5, numerator of the first term, I find 7 plus root 5 whole square. Plus, when the LCM I divide with the denominator of the second one, I find 7 plus root 5, 7 plus root 5 is getting cancelled, 7 minus root 5 is multiplied with the numerator of the second one, and I find it is 7 minus root 5 whole square. And this term I made it equalize to a plus 7 by 11 root 5 into b. Now 7 plus root 5 whole square plus 7 minus root 5 whole square, I can open this bracket, but if I will use this identity that a plus b whole square plus a minus b whole square, it is 2 whole into a square plus b square, I can write it is here 2 whole into 7 square plus root 5 square. I can use this curly braces. So 2 whole into 7 square plus root 5 whole square. So what identity I have used? I have used identity, let me write. Here it is 7 minus root 5 into 7 plus root 5. It becomes a square minus b square. So this is 7 square minus root 5 whole square. And finally this is equal to a plus 7 by 11 root 5 into b. So I have used this identity a plus b whole square. Sorry, let me write it here now. It will be a plus b whole square plus a minus b whole square equal to 2 whole into a square plus b square. This identity I have used. Okay, so I have used this identity. So by using this identity, I reached up to this term. Let me draw from the upper part. We reached up to this part. Let me draw this question part, we will solve it again. Now we will find this part, we have 2 whole into 7 square is 49 plus root 5 square is 5 divided by denominator is 7 square is 49 and minus it is 5. So 49 minus 5 is equal to a plus 7 by 11 root 5 into b. Now what I get at here now? This is 2, 49 plus 5 becomes how much? It is 54 divided by 49 minus 5, it becomes 44. Okay, so let me write it as 54, 2 into 54 by 44 is equal to a plus 7 by 11 root 5 into b. Okay, so then 2 into 54 now becomes 108 by 44 is equal to a plus 7 by 11 root 5 into b. So now this cancelling this part, I can find this will, I can cancel with 4. I will find it is 2 and 7, 27 by cancel with 11 equal to a plus 7 by 11 root 5 into b. Now I can find in this expression, this left hand side expression has only a rational term. And the right hand side expression has two terms, one is rational, other is irrational. So equalizing both the terms I can find, so 27 by 11 equal to a plus 7 by 11 into root 5 b. Here a equal to 27 by 11, and if you equalize this irrational part of both the sides, you will find there is no irrational part on the left hand side, we find it is b equal to 0. Here we can find this is a linear equation in two variables. Here a and b, there are two variables. As there are two variables in this equation, we can have many possible solutions of a and b. So such type of equations will be taught in the chapter linear equation in chapter number 4. So we can find many values of a and b. You can also try many more. So in such type of example, I can find how to find the value of a and b from solving this rationalizing factor. Okay. So what we learned today? We learned today how to operate rational number with irrational number and irrational number with irrational number, and how to find the rationalizing factor of the denominator of irrational numbers, and how to simplify these terms. Okay, so next we'll learn about some more rational expressions in the exponential factors. Okay, so this much is for today's class. Thank you.